Hi, this is Chris with Sanderson Test Prep, and we are taking a look at the May 2021 SAT. This is section 3, the No Calculator Math section, and let's go ahead and dive into these questions. So if we take a look here at number 1, it says 2 lines intersect as shown, what is the value of x? So the principle that they're testing here is to see whether or not we know the relationship of what we call vertical angles. So these two angles here are vertical angles, and vertical angles, or angles that are across from each other, the way that we see it displayed here, are always going to be equal. So what we do to solve this is we set those two expressions equal to one another. 5x plus 5 equals 7x minus 35. And from here we combine like terms. If you subtract 5x from both sides, you'll end up with a 2x over here. And I like to go that direction. You could go the other direction. You could subtract 7x so that your variable is on the left. Some people prefer that, but that would leave us with a negative 2x. I always like to try to keep the coefficient positive if possible. And then from here we add 35 to both sides. We get 2x equals 40. Divide both sides by 2. And x will equal 20. So answer choice B for number 1. All right, let's go ahead and move on and take a look at number 2. This is an absolute value question. So it says, what is the positive solution to the given equation? And it is important to know that for absolute value, you really do have two possible equations that can result. You have both the potential positive and negative results. So here we can try both. The positive one we like, because that one we basically just get to ignore the absolute value signs. You can drop the absolute value signs and rewrite the equation as is without the absolute value signs. For the negative version, you're going to keep the expression inside the absolute value the same, and then you're just going to switch the sign of the number that it's equal to. So this would now be equal to negative 8. And we could solve both of these. So here, when you add 4 to both sides on this first one, you get 2x equals 12. And then you divide by 2. X equals 6. Now they said, what is the positive solution? Right? And so if it says positive solution, and the solution that we got when we solved that first absolute value equation was positive, then we're good. We're done. We can pick answer choice C and move on. You don't even have to worry about solving this other negative equation. The way that the question is phrased, it lets us know that if we did go through and solve that, we would come up with a negative solution, and that's not what we're looking for here. So they want the positive one. We got the positive one on the first try with only working with the positive version of our absolute value expression, and we're good to go. Pick our answer and move on. All right, let's take a look at number 3. So 3 is going to be a little bit more difficult, but we're going to also look at an opportunity to apply a strategy here. So first, let's look at the traditional math way of doing this. Which of the following is equivalent to 4x cubed plus 8x squared? So the way that our answer choices are displayed, most of them show that we have something times a parentheses, meaning we've factored something out from this expression. So here, let's take a look at these and ask ourselves, what do they have in common? What are they both divisible by? Well, hopefully we can look at this and say, all right, well, let's look at the coefficients first. 4 and 8. What number goes into both of those? And hopefully you look at that, you say, oh, well, 4 goes into both of those. So we could factor out a 4. And when I say factor out, it basically means that you are dividing each term in the expression by a 4. And now we have to look at the variables, and we say, what are they both divisible by? And when you have exponents, I like to rephrase this by asking, how many x's do they share in common? So this one, x cubed, has x times x times x. There are 3 of them. This one has x squared, x times x. There are 2 of them. So they only have the two that are in common, right? That first expression with the x cubed has one extra x. So when we think of what we can divide by or what we can factor out, at most we can divide by or factor out x squared because they both have at least two of the x's. So whenever there are variables with an exponent and you're figuring what do I factor out, it's always going to be whichever one has the smaller exponent is what you're able to factor out. So we can factor out an x squared. And again, that's the same thing as saying divided by x squared. And if we're being really savvy test takers, when we get here, we can look at our answer choices and say to ourselves, hey, you know what? I only see one answer choice that has 4x squared times something. So I already know that it's answer choice C. I don't even have to figure out what goes in that parentheses. And that, if we're able to do that and save a few seconds, that's great. That's a big plus on test day. But just so we can see the rest of it as far as the traditional math is concerned, let's see what it looks like if we were to actually factor out that 4x squared and see what we're left with inside. So when we divide this, the 4's cancel, x cubed over x squared. So you subtract those exponents, that will leave you x to the first. Here, 8 divided by 4 is going to be 2 over 1, which is just 2. And then the x squareds cancel out. So this would just be plus 2. And we see that that does, in fact, match up with answer choice C. So that's how we answer question 3 using traditional math. Now let's say we're not big fans of traditional math. And if not, hey, that's fair. Not everybody loves doing it the traditional math way. So let's erase everything here. Let's see if we can apply a strategy on this. So here, what we teach at Sanderson Test Prep is how to see questions differently. And for this, let's see if we can see it differently. Which of the following is equivalent? So whenever you see variables in your answer choices, that lets you know that this is potentially what we at Sanderson Test Prep refer to as a PAM question. This is a good PAM question. And PAM stands for pick, answer, match. And it's a strategy if we want to avoid some of the algebra or maybe some of the traditional math that might be a little cumbersome, take a long time, or be confusing to us. Let's see if there's a more concrete way of doing this. So first we're going to try to pick a number. And we're going to pick a value for x. We don't want to make our lives difficult. And remember, this is the no calculator section. So I don't want to pick x equals 17 because 17 cubed is extremely difficult to do in your head and probably takes a long time to write out manually and make sure that we get right. But I also don't want to pick something that's going to make all of my answer choices similar. So if I said x equals 0 and plugged that in here, well then this expression comes out to be 0. And so does every single answer choice. We get 0 times anything, which is 0, across the board. So that doesn't help us differentiate among our answer choices. So we still want to pick a nice small value if we can, but something that allows us to differentiate among our answer choices. So let's try something like x equals 2. And now we can answer our question. So that's the A in PAM, pick, answer, match. So here, if we answer this, we plug in a 2. And 2 cubed, remember order of operations, so we do the exponent first here. 2 cubed is 8 times 4 is 32, plus 2 squared, which is 4, times 8, which is also 32. And we add those together and we get 64. Okay, cool, but what does that mean? Well, to answer our question, I'm going to have to plug into each answer choice, and then whichever one matches the answer that I calculated here, that's going to be my correct answer. So let's see what this looks like. For A, this would be 12 times 2 to the 5th. Well, 2 to the 5th is 32. And without even doing the exact math, because 12 times 32 is really difficult to do, but even if I did 10 times 32, I'm already at 320, which means this would be way too big. That's not going to be equal to 64. Let's try the next one. This would be 12 times 2 squared, or 12 times 4, which would be 48. And then 2 times 2, when I plug in my 2's everywhere, so plug in a 2 here, plug in a 2 here. 2 times 2 is 4 plus 1 is 5. 48 times 5. Again, I don't always have to do the exact math to recognize whether it's going to match or not. And you shouldn't do the exact math if you don't have to. Let's make sure we save some time on test day. So here 48 times 5 is going to be something way bigger than 64. Comes out to 240. But even if we just recognize, hey, it's bigger, that's out. Next one. So here, 4 times 2 squared. Well, when I plug in my 2's, so 2 squared is 4, so that's 4 times 4, which is 16. And then times your parentheses, 2 plus 2, which is 4. 16 times 4. Hey, that is 64. That matches. But just to be sure, let's plug it in for D as well and just make sure. So here we do 2 squared and then times 12 plus 2. So this would be 4 times 14. And if you know that off the top of your head, that's great. But if not, it at least looks like we might be close, right? 4 times 10 is 40. 4 times 14 is going to be a little bit more than 40. We might get close to 64, so we should probably take the time to just do the calculation and make sure on this. And if you do 4 times 10, which is 40, 4 times 4, which is 16, add them together, this comes out to 56. So that doesn't match. Our correct answer on this is C. So we look at the different ways of doing this problem. One thing that we want to take away from this is that if you know the traditional math and you're really comfortable applying it, then great, because sometimes that's the most efficient way to get to your correct answer. But sometimes it's also a little bit more difficult and requires a little bit more background knowledge. So if you don't know that traditional math, if you aren't as comfortable factoring an algebraic expression like this, then using PAM, pick, answer, match, is a great strategy to allow us to answer what otherwise would be an intimidating question a little bit more manageably. Take a look at our next video and we can see what the rest of the questions in this section look like. Thanks for watching.